So for the next 30 minutes or so, I'm going to be discussing new forms of human and machine collaboration, the impact that's having across industries, including healthcare, and the potential for impact in clinical development. Now, Paul Doherty, let's get up that first slide. There you go, human plus machine. Paul Doherty, Accenture's Chief Technology and Innovation Officer, recently co-authored a book on this subject, and the central premise of that book, which is called Human plus Machine, Reimagining Work in the Age of AI. The central premise is that plus sign between human and machine. Because despite everything Hollywood would like us to believe, everything we're doing now, all the work we're doing, all of our research, our view into the future, is that we're entering an age of human empowerment where technology will augment humanity and fundamentally improve the way we live and work. And the ideas and concepts expressed in that book are really relevant to healthcare, and that's what I wanted to explore today. The challenge for everyone in this room is how can you translate those ideas into solving challenges and obstacles, not only in the trial of tomorrow, but the clinical trial of today. So, as we think about human-machine collaboration, new forms of collaboration that are unlocking new value, we think about three key trends that are driving this transformation. The first is the growth of smart objects, smart devices, smart products. The second is new forms of interaction with those devices. And the third is new forms of AI that are underpinning everything. And we think the combination of those three advances are going to change the opportunities for research across industries, healthcare included. So the first trend was the growth of smarter objects, smarter devices, smarter products. And when I talk about this, I think about these devices as operating at the edge of the network. You think about the internet as the network and the cloud is the center. Where that cloud touches the physical world, that's the edge. It's where the devices live that input data to the cloud. That used to be punch cards back in the day, and then it became keyboards and mice and styluses, and now predominantly it's actually sensors feeding data through these input pathways at the edge of the cloud. And the sensors that we have at the edge are getting really, really intelligent, really smart. And I'm not talking about a smartphone or a connected health wearable or a regulated device. I'm talking about everyday objects that we interact with either passively, smart cameras, air pollution sensors and so on in smart cities, or directly, household appliances, cars and so on. Those objects are getting really, really smart, and we think they're going to play an increasing role in our healthcare. So stepping back for a second, I know what you're thinking. Even introducing a smartphone and a connected wearable in a study today introduces challenges, complexities around technology, around process, around regulatory. And Medidata and Accenture and other companies are helping you with that today. But if you step back for a minute and you think about what's happened with connected health devices, even in the last 3 years, where 3 years ago, many players stepped away from the market and the whole market consolidated, and there was a thought, is this market really going to be a growth market? And from there, it not only grew, it accelerated exponentially. And what's driving that acceleration is consumers' willingness to engage with these devices for purposes of healthcare. So we think about connected health devices as having entered the third generation, which is what we call beyond the wrist, and into the fourth, which is having medical and clinical relevance, not being directional, but being actually medically accurate. And so we think about moving beyond the wrist from wrist-borne trackers into new forms of monitoring in-ear, extremities, and so on, and of course, smart clothing. Even as it is today, smart clothing offers really unique opportunities to measure behavior, activity in really challenging circumstances when maybe cognitive function is a real part of disease progression and so on. But connected health devices continue to evolve, and of course we now have examples that you're familiar with, Proteus and ingestibles and so on, but also injectables. An interesting startup came out of stealth mode about 3 weeks ago called Glimpse Bio, who are developing nanoparticles designed to interact with the enzymes associated with disease and release chemicals that are collected in urine. And so they're looking to outperform naturally occurring biomarkers with nanotechnology. But I said at the start that I wasn't really thinking about connected health devices. I'm thinking more about everyday objects that we interact with both passively and directly. Because globally, there is a massive transformation underway where the products, the objects, the devices that we interact with are less and less about a hardware-only platform and more frequently containers for sensors and software. Now, Accenture every year releases a tech vision that you can get online, and that's the tech vision for 2018 I'm showing you there. It looks at 5 key trends that we think are critical to strategy and planning and implementation for technology. And you can see the 5th trend there called the Internet of Thinking. Now, I know we were all only just getting used to the Internet of Things, but at the party tonight, in other words, you can say, hey, that's so last Tuesday. It's now the Internet of Thinking. And what we mean by that is what I said. The sensors at the edge of the network are getting so intelligent, they're starting to think. They're starting to autonomously act and sense and apply analysis. They have machine learning. They have intelligence built in. And they're able to not transfer raw data, which is what we did in the Internet of Things. They're able to analyze the data, create a determination, and send an analysis back to the cloud. And that's the Internet of Thinking. And why now? Well, we simply couldn't gather all the data and transfer it over the network if we wanted to. We don't have the bandwidth. And if we did, we couldn't possibly store it all. In addition, the latency that would be created by waiting for a compute function in the cloud and an answer to come back to us, that wouldn't support use cases like autonomous and semi-autonomous vehicles, like robotic surgery devices, and so on. Now, I know every single one of you who are into data science right now are thinking, but we need all the data. We can't have it. There's too much. We're generating too much at the edge, and these devices are creating new forms of intelligence. Some examples. Smart cameras used, for example, in smart city implementations where the cameras are monitoring pedestrian flow and traffic flow and so on. They're not sending that raw footage over the wire to a cloud compute service. They're analyzing the data in front of them using computer vision. They're counting pedestrians, which, by the way, is good from a privacy perspective rather than sending raw footage. And they're also analyzing traffic. And the intelligence in the cameras today is so advanced that we're able to not only count the traffic, we're able to determine, with the addition of vibration data as well, what kind of traffic it is. So the cameras can determine that's an 18-wheeler with a certain load. It's an SUV likely with 3 passengers, and so on. So these devices are really smart. Another example is farming. Smart farms use drones and autonomous vehicles to improve hydration. So we're not talking about hydrating entire crops. We're talking about using sensors to determine exactly where hydration is needed. And also pesticide application. A great example, drones use computer vision to determine which crops are diseased, which need pesticide, and only apply pesticide to those crops that need it. Imagine the value that creates rather than applying pesticide in blanket to every crop. And of course, there's no better object or product that has moved from, no better example, that has moved from a hardware-only platform to essentially a container for sensors and software than our car. So the premise here is, do we think, with the growth of all of these objects in our environment that are able to measure our environment and the way we interact with it, do we think the digital health of the future will be bound by our smartphone and a wearable? When the mirror we use in the morning can detect changes in skin condition and eye health, when the bed we sleep in at night can detect sleep patterns, interruptions in body temperature, when the bus stand, the bus shelter that we stand at waiting for a bus is not only measuring air pollution, it's listening for coughing to detect the potential spread of infectious disease. I'm not kidding with that one. It exists and it's out there. And of course, to our car. When a car understanding we're diabetic and having access to our connected glucometer data can analyze our driving patterns, maybe the composition of our sweat, and warn us that we're at risk of an impending hyperglycemic event. I think it's much more likely that these objects, these smart devices and products, are going to play an increasing role in our healthcare, and they're going to create new data and new opportunities for insight that's going to change research. Second big trend, new forms of interaction with those objects. And I'm going to show you a really literal example and help you draw the parallel into clinical development in a minute. A really good example of new forms of interaction is coming from cobots. A quick show of hands. Who has heard the term cobot before? Some. Okay, great. So there's new learning. Cobots are smart, intelligent robots that are designed to interact with humans and collaborate. Collaborative robots. Cobots. They use sensors, computer vision, and so on, and they're designed to work with humans, to be that human plus machine value equation. And humans are able to train cobots through touch, through guidance, through computer vision, and the cobots learn from humans to achieve tasks, typically in a production and assembly facility. A good example is Mercedes-Benz. In a plant in East Germany, Mercedes processes 1,500 tons of steel a day to produce 400,000 vehicles a year. And with that scale of automation, you would imagine a fully robotic automated assembly line. But what Mercedes have started to do is replace some of their production lines with cobot lines, collaborative robots and humans. And what's driving that is the personalization that consumers are able to create for their vehicles. Because consumers can now create hundreds of different variations of vehicle. Gone are the days of 3 trim levels. And Mercedes have proven that robotic, fully automated production lines are not good at handling that amount of variation, whereas collaborative lines with robots and humans can, and they're more efficient. And cobots have made their way into life sciences, of course. They're in manufacturing, as we discussed. They're in some labs, sorting and handling lab samples. And of course, a great example is surgical robots, right? And I'm not suggesting that cobots are particularly relevant to clinical development. But what is interesting is the whole push in the field of human-computer interaction research that cobots are driving. They're driving research into new ways for humans and robots, humans and technology, humans and automation to interact. I am going to, I think, do we have the video? Let's see.
In order to support ad hoc improvisation, we are exploring lots of different ways for humans and robots to communicate with each other. One of the things that we're exploring now, for instance, is communicating via gesture. We have some technology. We're playing with gloves. We have an armband. We have various kinds of sensors that allow our robot to be able to detect what gestures you're making. And what we're trying to explore now is what kind of gesture language can be easily detected but can also be powerful enough for us to communicate successfully to the robot a key change to the plan. And how then does the robot communicate back in a way so that the human team member is comfortable that they understand each other?
So the question is, do we think new forms of interaction like gesture, haptic, and touch and so on have the potential to increase participation and diversity in clinical trials for those candidates and participants and patients who can't maybe use a smartphone? Absolutely. And of course, no discussion on new forms of interaction will be complete without talking about the growth in conversational interfaces. Okay, quick show of hands. Who recognizes that particular conversational machine? Wow. Okay, I thought more. That's HAL 9000 from 2001: A Space Odyssey. You all need to go stream that movie tonight. Because that robot was not a force for good in that movie. That movie's going to flip everything I'm talking about on its head. Okay, so conversational machines really changing the way we think about interaction with technology and impacting healthcare. One good example is the rise of chat services, chatbots powered by AI. Every parent of a teenager knows most of their time is spent on the lock screen and on instant messaging platforms. That's where the users are, so that's where the technology has gone. And enabling conversant chat systems is proving very effective for organizations to help consumers navigate complexity, and what's more complex than our healthcare system. And in fact, I showed you Accenture's Tech Vision from 2018 earlier. Last year's Tech Vision had as one of its 5 trends, AI is the new UI. Artificial intelligence is the new user interface. And what that's referring to is the rise of these kind of chatbot interfaces where brands are more and more interacting with consumers through AI-powered chat. Of course, voice first. Clearly a major development in the last 2 to 3 years. And it's being driven really from a technology perspective by increased accuracy in natural language processing and accuracy. In fact, for the last, 10, 15 years, it was hovering at 80%, and you really need to get into the 90s to enable natural conversation. Also, one of the other big advances was latency, where latency came from 5 seconds down to 1.5 seconds and below, and that's what you need, again, for natural interactions via voice with the growth and improvements in cloud compute. So when you think about all the potential ways conversational machines can impact healthcare, I thought what would be helpful is to break those down into 4 categories that we could articulate and discuss, going from operational through assistive into advisory and clinical, with increasing medical and clinical relevance as you go left to right. I'll show you some examples. Operational. Simple, what we call narrow AI. That means an AI doing a set task to carry out a limited set of useful functions, meaning transcribe voice and speech to text, or carry out a certain set of instructions. It's narrow because it's a very slim definition of AI, and it's what's very prevalent today. And you can see the time savings that Accenture have looked at for doctors and registered nurses, but in fact, about 18 months ago, we did an analysis of the top 10 applications of AI in healthcare, and the third, by value that it would produce to 2026. And the third most valuable application of AI in healthcare was administrative workflow assistance, and that's voice transcription is a large part of that. $18 billion in value generated by 2026. The next category is assistive, and we're seeing a significant growth in assistive systems where users, consumers, patients are assisted to navigate complexity through typically chat interfaces. Orderly is a great example. Scheduling appointments, carrying out pre-appointment checklists and briefings, choosing between options, commercial options, health plans, and so on. The next category, though, is really a significant leap, because the artificial intelligence required to power an advisory service is very different from the narrow AI that we've seen in assistive and operational. Because the attributes of an advisor is that an advisory service has to know us as a consumer, as a patient, for a much longer period of time. It has to build a profile of us based on our preferences, but also our behaviors and activities. It has to be able to filter content based on our preferences. It has to be able to suggest new content and optionalities to us, watch over us for harm in terms of making decisions, and connect us to other useful services. So the capabilities of a true advisor service are very different from assistive services. And there are some that are coming to market that are starting to do that. Some using avatar technology, as in the case of Sensely, and one that I'm sure most of you will have heard of is Babylon over in the UK, which is using a very powerful AI underneath the chat engine to do symptom triage. And then critically, and if you remember that what we're talking about is human plus machine, it's taking that relatively narrow but powerful AI and connecting it to human services in the form of GPs, specialists, and therapists in telehealth. And it's that combination of AI plus human is creating a winning service for Babylon. And so where do we get to when we think about voice and conversational interfaces in clinical studies? Well, of course, for ePro, that makes obvious sense. But beyond the quantitative nature of what a patient or a consumer or a candidate or a participant might say to a conversational machine, particularly in a voice-first instance, we're really interested in the qualitative nature of what's said, the behavioral aspects of how we speak, turn-taking, repetition, interruption, frustration, emotion. All of these factors create a vocal biomarker that we can use to assess whether a patient is engaging with a service, whether they're likely to drop out of a service. And this is real relevance when we think about challenges in clinical. Last observation, the third trend is that new forms of artificial intelligence will power everything. And I've been talking about AI throughout the other two trends as well. If you think about AI, we describe it as a spry 70 or 80-year-old because although it's existed since 1950, it's only really in the last 5 to 7 years that new forms of machine learning have empowered applications like computer vision and so that have become really commercially, have penetrated from a commercial perspective. And although I know that slide says 2000 today is the third boom, like I say, it's really the last 5 to 7 years. And we know that's advancing. We can see both the value, the levels of funding that are being introduced into the AI community, as well as the sheer number of data science and AI startups that are getting funding. And it's particularly relevant in life sciences and healthcare. However, we still think when you think of human plus machine, there is a missing element that is what we're working on right now. We call it collaborative intelligence. Because if you think about what a human is good at, articulation, communication, improvisation, generalization, exploration, and what a machine is good at, repetition, memorization, prediction, we need new ways to bring those two ends together to unlock new value pools. And we think there's a lot of opportunity in that middle space that we call the missing middle to create new solutions that are based on collaborative intelligence. So I want to step back for a minute to assistive technologies, that second type, and just show you a little bit about some work that we've done in Accenture's Tech for Good program. That program is where Accenture Labs globally assigns budget each year to use the latest technology in our hands to solve issues around societal need. And I want to show you an application of assistive technology that relies on smart objects, new forms of interaction, and AI to underpin a solution that is really life-changing. So I'm going to see if we can play the Drishti video, please.
India has the largest population of the blind. From past 65 years, we have been empowering the visually challenged persons to bring them in the mainstream society with the assistive technology, and we have employed people in the mainstream industry like banking, telecalling, medical transcription, and all other aspects where we can bring them in the mainstream society.
Accenture is co-innovating with National Association for Blind, India, to build guided assistive solutions leveraging latest artificial intelligence technologies. Accenture has developed an accessibility solution called Drishti. Drishti is an acronym for disambiguating real-time insights for supporting humans with intelligence. Drishti also means vision, and it helps blind people derive insights that enhances the way they live and work. The solution leverages multiple industry-leading artificial intelligence services from Microsoft and others to describe the world around the visually challenged person. Accenture Labs' research in natural language processing is used to aggregate, disambiguate, infer, and generate a coherent narration of the world for the visually impaired.
This solution leverages some of the latest artificial intelligence technologies as well as natural language processing, and it gives the blind people a real-time insight of what's happening around them.
It is a dream come true for blind people. This software will enable us to see the world which we were unable to see previously.
Drishti helps identify objects around the user.
Analyzing the scene. I think there is a cell phone on the table. On deeper analysis, I think it is a black Samsung Galaxy Android phone.
The solution provides natural language generation capability to describe the scene to the visually challenged person. Drishti also narrates English text from printed books and documents using optical character recognition.
Analyzing the scene. I think it is a book on a table. On deeper analysis, it is God's own kitchen book.
The solution uses human-centric design principles and can integrate with smart glasses like Pivot Head to support the visually challenged with information with just a tap on the mobile screen.
Scene captured. Analyzing the scene, I think it is a white sedan.
Smart glasses like this have a camera inbuilt, and then it becomes very interesting because it will talk via Bluetooth to the accessibility solution, and then all you have to do is wear this glass, and as you tap on your cell phone, you can see and hear more about the world around you.
It was very difficult for me to identify the glass doors which are there in these corporate buildings, and I used to bang on those glass doors. But now with the solution created by Accenture, helps me to identify those glass doors.
Analyzing the scene, there is a glass door in front of you.
And with the support of this solution, I can walk into those doors without hurting myself.
The solution can be used to describe the close surroundings.
Analyzing the scene. 2 people were detected. Age 37.3 years old male who is smiling. And 35.2-year-old male who is smiling.
The solution also incorporates responsible AI by ensuring data privacy and not storing any images internally. Drishti can also be used to identify new Indian currency notes, which is often confused with lower denomination notes by the blind.
After demonetization, it has become very difficult to identify the currency, but the solution supports me even to identify those new currencies, which is very helpful so that I cannot be cheated.
Analyzing the scene. I think this is a 500 Indian rupee note.
We are very happy to say that this is a solution a lot of people are using, and they are feeling that they're getting more empowered to lead a normal life.
I can say that this software is a Drishti, like it is a true vision for us. I must thank all developers of this software. I must congratulate them for taking this step to make our lives meaningful and fulfilled.
Pretty cool, right? So, does all of this really matter? I'm not suggesting that smart objects and new forms of interaction and new AI necessarily go directly to support new endpoints, but do I think that they can increase participation and diversity for people like you saw in the Drishti video who have impaired vision or are blind to participate and enable them to participate in a virtual trial? Absolutely. Because the reality is there's competition in the ecosystem. Sponsors are vying for some of the same investigators, and those investigators are advocating for their patients' health. And one of the questions they ask is, who has the best technology? And that means the molecule, yes, but it also means the technology surrounding the design and execution of the trial, and the ability to remove obstacles and challenges, improve engagement, improve participation and diversity. And it's really in line, actually, if you think about what Medidata are doing with RAVE, opening up new sources of data, new real-world evidence, and enabling the future for virtual trials, it's exactly in sync with that idea. I do want to thank Medidata. These kind of events where we come together and we collaborate, they're enormously important. They're a really great partner for Accenture, and we really value working with them. If you fundamentally disagree with absolutely everything I've said today, my name is Ian Schaefer. If you like what I said, I'm Ronan Wisdom. I really appreciate your attention. I've enjoyed speaking with you. I hope you enjoy the rest of the event. Thank you.